Hello everyone, my name is Madhuri Gupta, Assistant Professor, Department of Computer Science and Engineering, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today's topic is Constant Satisfaction Problem, CSP. Before that, let's have a quick recap on last lecture on AND OR graph. So, about AND OR graph, in the realm of artificial intelligence, certain graphical representation help streamline complex decision making processes. One such tool is the AND OR graph. In the quick recap, we will explore what an AND OR graph is, its components and its role in problem solving. Segment 1, what is an AND OR graph? An AND OR graph is a graphical representation used to model the flow of information and decision in a problem solving process. It is particularly useful for representing the complex relationship between multiple conditions, decisions and sub-goals in AI systems. Segment 2, components of an AND OR graph. An AND OR graph consists of two types of nodes, AND nodes and OR nodes. So, what is AND node? AND node represents condition or sub goals that must be true or achieved simultaneously. The flow of control continues only when all the incoming branches are satisfied. OR nodes. OR node represents alternative choice or options. The flow of control continues if at least one incoming branch is satisfied, indicating that one of the choices is viable. And the segment 3, problem solving with AND OR graph. AND OR graph are commonly used in problem solving, especially in areas like automated reasoning and expert systems. They provide a structured approach to navigate complex decision trees and identifying viable paths to solutions. And in our next segment 4, we have some example scenario. Imagine an expert system diagnosing a medical condition. The AND nodes could represent essential symptoms that must all be present for a particular diagnosis. The OR node could represent different possible diagnoses based on the presence of specific symptoms. Segment 5, we have benefits and applications. So, we have structured decision. We have structured decision making. AND OR graph provide a clear structure for breaking down complex decision into manageable components. Efficient problem solving. They help AI system efficiently navigate decisions tree, reducing redundant computations. Expert systems. AND OR graph are commonly used in expert systems for medical diagnosis, troubleshooting and decision support. And in our segment 6, we have conclusion about AND OR graph. In essence, the AND OR graph is a viable tool in AI problem solving, allowing us to model intricate relationships between conditions and choices. As AI continues to evolve, mastering tools like AND OR graph help us navigate complex decision making landscapes more efficiently. So, now let us start our today's topic on constant satisfaction problem. So, here is the overview of constant satisfaction problem. Constant satisfaction problem or CSP is a fundamental topic in artificial intelligence that deals with solving problem by identifying constraints and finding solutions that satisfies those constraints. CSP has a wide range of applications including scheduling, resource allocation and automated reasoning. So, let us start with the introduction. The goal of AI is to create intelligent machines that can perform tasks that usually require human intelligence, such as reasoning, learning and problem solving. One of the key approaches in AI is the use of constant satisfaction technique to solve complex problems. CSP is a specific type of problem solving approach that involves identifying constants that must be satisfied and finding a solutions that satisfies all the constants. CSP has been used in a variety of applications including scheduling, planning, resource allocation and automated reasoning. So, what is constant satisfaction problem? Let us have the quick understanding. A constant satisfaction problem in an artificial intelligence involves a set of variables, each of which has a domain of possible values and a set of constants that define the allowable combinations of values for the variables. The goal is to find a value for each variable such that all the constants are satisfied. More formally, a CSP is defined as a triple X, D, C, where X is a set of variable x1, x2 up to xn. D is a set of domain d1, d2 and up to dn, where each di is the set of possible values for xi. C is a set of constants c1, c2 up to cm, where each ci is a constant that restricts the values that can be assigned to a subset of the variable. The goal of a CSP is to find an assignments of value to the variables and satisfies all the constants. This assignment is called a solution to the constant satisfaction problem. So, now have a look of solving constant satisfaction problem. A state space. Solving a CSP typically involves searching for a solution in the state space of possible assignments to the variables. The state space is a set of all possible configurations of variable assignments, each of which is a potential solution to the problem. The state space can be searched using various algorithms including backtracking, forward checking and local search. The notion of the solution. The notion of a solution in CSP depends on a specific problem being solved. In general, a solution is a complete assignment of values to all the variables in a way that satisfies all the constants. For example, in a scheduling problem, a solution would be a valid schedule that satisfies all the constants on task scheduling and resource allocation. Domain categories within CSP. The domain of a variable in a constant satisfaction problem in artificial intelligence can be categorized into three types: finite, infinite and continuous. Finite domain have a finite number of possible values such as colors or integers. Infinite domains have an infinite numbers of possible values such as real numbers. Continuous domains have an infinite number of possible values, but they can be represented by a finite set of parameters such as the coefficient of a polynomial function. In mathematics, a continuous domain is a set of values that can be described as a continuous range of real numbers. This means that there are no gaps or interruptions in the values between any 2 points in the set. On the other hand, an infinite domain refers to a set of values that extends indefinitely in one or more directions. It may or may not be continuous depending on the specific context. So, now we have types of constant in CSP. Several types of constants can be used in constant satisfaction problem in artificial intelligence, including unary constants. A unary constant is a constant on a single variable. For example, variable not equal to red. Binary constant. A binary constant involves two variables and specifies a constants on their values. For example, a constant that two tasks can be scheduled at the same time would be a binary constant. Global constants. Global constants involve more than two variables and specify complex relationship between them. For example, a constant that no two tasks can be scheduled at the same time if they require the same resource would be a global constant. So, in summary or in conclusion, we can say that constant satisfaction problem in artificial intelligence is a fundamental topic that involves identifying constants and finding solutions that satisfies those constants. Various algorithms including backtracking, forward checking and local search can be used to search the state space and find a solution to the CSP. So, one of the method of constant satisfaction problem is cryptarithmetic problem in AI. So, what is cryptarithmetic problem? Cryptarithmetic problem is a type of constant satisfaction problem where the game is about digits and its unique replacement either with alphabet or other symbols. In cryptarithmetic problem, the digit which is from 0 to 9 get substituted by some possible alphabets or symbols. The task in cryptarithmetic problem is to substitute each digit with an alphabet to get the result arithmetically correct. We can perform all the arithmetic operation on a given cryptarithmetic problem. The rule or constant on a cryptarithmetic problem are as follows. There should be a unique digit to be replaced. There should be a unique digit to be replaced with a unique alphabet. The result should satisfy the predefined arithmetic rules. For example, 2 plus 2 is equal to 4, nothing else. Digits should be from 0 to 9 only. There should be only one carry forward while performing the addition operation on a problem. The problem can be solved from both sides, that is left hand side or right hand side. Let us understand the cryptarithmetic problem as well its constants better with the help of an example. So, we have given a cryptarithmetic problem, that is cent plus more is equal to money. In this example, add both terms cent and more to being money as a result. Follow the below steps to understand the given problem by breaking it into its subparts. Starting from the left hand side, the term are S and M. Assign a digit which could be a satisfactory result. Let us assign S to 9 and M to 1. So, in this diagram you can see S is equal to 9 and M is equal to 1. So, by putting the value S is equal to 9 and M is equal to 1, we get the resultant as 10. Hence, we get a satisfactory result by adding up the terms and got the assignment for 0 as O. Means O is assigned 0 as well. Now, move ahead to the next terms E and O to get N as its output. So, in this diagram E plus O is equal to N. So, if we are putting E is equal to 5 and O is equal to 0, the resultant N is equal to 5, which cannot be feasible because both E and N has the same value. So, adding E and O, which means 5 plus 0 is equal to 0, which is not possible because according to cryptarithmetic constants, we cannot assign the same digit to two letters. So, we need to think more and assign some other values. So, in this diagram, we have to replace with by carry. So, if we carry this with 1, so we have the N is equal to 6. So, we have to note when we will solve further, we will get 1 carry. So, after applying it, the answer will be satisfied. Further, adding the next two terms N and R, we get N is equal to 6 and R is equal to 8. So, we have the total is equal to 14. So, which is also not possible, but we have already assigned E is equal to 5. Thus, the above result does not satisfy the values because we are getting a different value for E. So, we need to think more. Again, after solving the whole problem, we will get a carryover on this term. So, our answer will be satisfied. So, now let us have, we have N is equal to 6 and R is equal to 8 and we have carry 1. So, we have total as 15, that means we have carry forward is 1 and we have value of E is equal to 5, where 1 will be carry forward to the above term. Let us move ahead. Again, on adding the last two terms, that is the rightmost term D and E, we get Y as its result. So, we can put D is equal to 7 and E is equal to 5. So, we have total 12, which means 1 should be carry forward, where 1 with carry forward to the above term. Keeping all the constant in mind, the final resultant is as follows: cent plus more is equal to money. So, below the representation of the assignments of the digits to the alphabets. So, we have S is equal to 9, E is equal to 5, N is equal to 6, D is equal to 7, M is equal to 1, O is equal to 0, R is equal to 8 and Y is equal to 2. So, finally, we have solved this problem, send more money. So, now we have more example of cryptarithmetic problem. So, first one is base plus ball is equal to games. So, by using the above method, you can solve it and the final solution will be B is equal to 7, A is equal to 4, S is equal to 8, E is equal to 3, L is equal to 5, G is equal to 1 and M is equal to 9. We have another example, your plus U is equal to heart. So, by solving this, we get Y is equal to 9, O is equal to 4, U is equal to 2, R is equal to 6, H is equal to 1, E is equal to 0, A is equal to 3 and T is equal to 8. Similarly, We can also perform multiplication on the cryptarithmetic problem. As an example, we can say that two words base and ball and the result is games. Now, if we try to add base and ball by their symbols digit, we will get the answer games. Note, and minute there must be 10 letters maximum, otherwise it cannot be solved. So, we have input and output. This example will take 3 words base, ball and games. So, we have the output, it will show which letter holds which numbers from 0 to 9. For this case, it is like this: letter A value is 4, letter B value is 2, letter E value is 1, letter G value is 0, letter L value is 5, letter M value is 9 and letter S value is 6. So, we can put all the value together. So, we got base 2461, ball 2455 and for games we have 04916. So, we have algorithm for this problem. For this problem we will define a node which contains a letter and its corresponding values. So, we have function is valid, node list, count, word 1, word 2, word 3. We have input, a list of nodes, the number of elements in the nodes list and 3 words. Output, true if the sum of the value for word 1 and word 2 is same as word 3 value. Begin, M is equal to 1 for each letter I from right to left of word 1. Do, CH, that means character, is equal to word I. For all elements j in the node list, do the following: if node list j letter is equal to ch, then break. Done. Value 1 plus m into node list j into value, m is equal to m into 10. Done. M is equal to 1 for each letter I from right to left of word 2. Do, character is equal to word 2 of I. For all elements j in the node list, do if node list j letter is equal to character, then break. Done. Value 2 is equal to value 2 plus m into node list j dot value, m is equal to m into 10. Done. M is equal to 1 for each letter I from right to left of word 3. Do, character is equal to word 3 of I. For all elements j in the node list, do if node list j dot letter is equal to character, then break. Done. Value 3 is equal to value 3 plus m into node list j dot value, m is equal to m into 10. Done. If value 3 is equal to value 1 plus value 2, then return true, return false and end. Now, the permutation node list count and word 1, word 2, word 3. The input, list of nodes, number of items in the list, number of assigned letters and 3 words. And the output, true when all letters are assigned with values correctly to solve the sum. Begin, if n letters are assigned, then for all digits I from 0 to 9, do. If digit I is not used, then node list n dot value is equal to I if is valid node list count word 1, word 2, word 3 is equal to true for all items j in the node list. Do show the letters and corresponding values. Done. Return true. Done. Return false. For all digits I from 0 to 9, do if digit I is not used, then node list n dot value is equal to I. Mark as I is used if permutation node list count n plus 1, word 1, word 2, word 3, return true, otherwise mark I is not used. Done. Return false. End. So, in summary, constraint satisfaction problem in AI has a wide range of application including scheduling, resource allocation and automated reasoning. Solving a constraint satisfaction problem in artificial intelligence typically involves searching for a solution in the state space of possible assignments to the variables. The notation of solution in constraint satisfaction problem in AI depends on the specific problem being solved and is a complete assignment of value to all the variables in a way that satisfies all the constraints. The domain of a variable in a constraint satisfaction problem in artificial intelligence can be categorized into three types: finite, infinite and continuous. Several types of constraint satisfaction Several types of constraints can be used in constraint satisfaction problem in AI, including unary, binary and global constraint. So, here is the quick tricks of solving cryptarithmetic problem very quickly. First, each letter will be assigned with an individual digits and no two letters will have the same number. Now, the main question arises when we have to find the unique digit assigned to each corresponding letter. Cryptarithmetic is considered to be both a science as an art. Hence, apart from logic, one must use his or her presence of mind and a little bit of common sense to solve the problem. Solve arithmetic. Question is how to quickly solve the problem. Question 1. Decode and solve the below mentioned cryptarithmetic problem. Cross plus roads is equal to danger. So, we have the solution. We have C5, that means carry 5. So, carry will start from the second rightmost of digit. So, C1, C2, C3, C4 and C5. So, we have C5 which is equivalent to D. Since it is already mentioned that the carry value of resultant cannot be 0, then let us presume that the carry value of D is 1. We know that the sum of two similar value is even. Hence, R will have an even value. Hence, S plus S is equal to R. So, R is an even number for sure. So, the value of R can be 0, 2, 4, 6 and 8. Value of R cannot be 0 as two different values cannot be allotted the same digit. If S is equal to 10, then their sum is equal to 20. Carry forward 2, then the value of R is equal to 0, which is not possible. If S is equal to 1, not possible since D has the same value. If S is equal to 2, then R is equal to 4, which is possible. Hence, S is equal to 2 and R is equal to 4. C4 plus C plus R is equal to A plus 10. C4 plus C plus 4 is equal to A plus 10. C4 plus C is greater than 5, being the value of carry will be generated when the value of C is generated, then when the value of C is greater than 5, C is equal to 9. C1 plus S plus D is equal to E. C1 plus 2 plus 1 is equal to E. Therefore, E is equal to 3. C4 plus C plus R is equal to A plus 10. C4 plus 9 plus 4 is equal to A plus 10. Therefore, A is equal to 3. But it cannot be possible as E is equal to 3. Now, let us consider S plus D plus C1 is equal to E. 2 plus 1 plus 0 is equal to 3. Therefore, E is equal to 3, making C2 is equal to 0 since 2 plus 1 is equal to 3. Now, let us consider the equation again. C plus R plus C4 is equal to A plus 10. 9 plus 4 plus 0 is equal to A plus 10. 13 is equal to A plus 10. Therefore, A is equal to 3, but E is equal to 3. So, A is not equal to 3. Again, considering R is equal to 6, so S is equal to 3, C4 is equal to 0. C plus R plus C4 is equal to A plus 10. 9 plus 6 plus 0 is equal to A plus 10. 15 is equal to A plus 10. Therefore, A is equal to 5 and S plus D plus C1 is equal to E. E plus 1, 3 plus 1 plus 0 is equal to E. Therefore, E is equal to 4 and C2 is equal to 0. Now, considering the equation R plus 0 plus C3 is equal to N. 6 plus 0 plus C3 is equal to N. So, 6 plus 0 plus C3 is equal to or equal to 3. Let C3 is equal to 1. Then O is less than or equal to 2. That is O is equal to 0, 1, 2. Let O is equal to 2. Again, considering R plus O plus C3 is equal to N. 6 plus 2 plus 1 is equal to N. Hence, N is equal to 9, but C is equal to 9. So, N cannot be equal to 9. Now, let N is equal to 8, C3 is equal to 0. Let us consider equation O plus A plus C2 is equal to G. Therefore, G is equal to 7. Hence, D is equal to 1, S is equal to 3, A is equal to 5, G is equal to 7, C is equal to 9, O is equal to 2, E is equal to 4, R is equal to 6, N is equal to 8 and C1 is equal to 0, C2 is equal to 0, C3 is equal to 0, C4 is equal to 0 and C5 is equal to 1. Now, verifying the above value in the equation, we get cross C is equal to 9, R is equal to 6, O is equal to 2, S is equal to 3, S is equal to 3 plus rows R is equal to 6, O is equal to 2, A is equal to 5, D is equal to 1, S is equal to 3. Danger, D is equal to 1, A is equal to 5, N is equal to 8, G is equal to 7, E is equal to 4, R is equal to 6. So, we have solved all the values for crossroads danger and it is arithmetically correct. In our next lecture, we will delving into an topic of artificial intelligence, the min-max search algorithm. This algorithm lies at the heart of decision making in games, optimization and various AI applications. Let us take a brief look at what you can expect to explore in this upcoming lecture. Understanding min-max search. We will start by unraveling the core concept of the min-max search algorithms. This approach forms the foundation for making decisions in situations where multiple players or agents take turns and compare and compete for the best possible outcome. In our upcoming lecture on min-max search, we will uncover the algorithm that empower AI system to make intelligent decisions in competitive scenario. By understanding its principles, you will gain insights into the strategic thinking and underlies many AI applications. Thank you for watching, and we will see you in the next lecture. Till then, happy learning.